Assalamualaikum warahmatullahi wabarakatuh and greetings to all audience. My name is Siti Aisyah Nadira binti Jaafar from Kuliah of Science, International Islamic University, Malaysia. Today, I'm going to present our research project entitled In Vivo Cytotoxicity Analysis of Bioceramic root canal sealers on Zebrafish Embryo. For the introduction, in vivo study is an experiment that performed inside living organism to allow the evaluation of embryo development, embryonic changes, and lifetime effects. Bioceramic root canal sealers are recently developed materials that used in root canal treatment procedure. Previous research focused on comparing the in vitro cytotoxicity analysis between conventional and bioceramic root canal sealers. But there was no comparison for in vivo cytotoxicity analysis between these bioceramic root canal sealers. Another aspect is in vitro study unable to reproduce in vivo conditions. Therefore, this study was conducted. The aims of this study: firstly, we want to evaluate the in vivo cytotoxicity of bioceramic root canal sealers. Secondly, we want to propose which material that have less cytotoxics for the root canal treatment procedure. For the first method, it is about zebrafish husbandry and egg production. Adult white-type zebrafish was maintained in a recirculating water tank in a specific room. Adult female and male zebrafish were chosen and kept in a fish tank for the egg production. Transparent eggs were observed and collected after successful of the spawning procedure. The second method is the preparation of A3 stock solution. Sodium chloride, potassium chloride, and magnesium sulfate with specific amount was dissolved in 1 liter of distilled water. Hydrochloric acid and sodium hydroxide were used to adjust the pH of the stock solution until it becomes 7.2 by using the pH meter. The third method is the preparation of the samples and extraction solution. Firstly, the materials such as Gutaflow Bioseal, MTA filler packs, Sarase Bioceramic root canal sealer, and IRSP root canal sealer were mixed according to the manufacturer's recommendation. Then, the materials were immersed in an appendix tubes that contain E3 solution and incubated for 24 hours. The last procedure is for the cytotoxicity evaluation of bioceramic root canal sealers on zebrafish embryo. Firstly, fertilized embryo were moved into 96 well plate and divided into 6 groups, which is positive control group, negative control group, and another 4 groups for each of the bioceramic root canal sealers. All plates were incubated. The zebrafish embryo were examined at 24, 48, 72, and 96 hours of post-fertilization by using digital camera linked to an inverted microscope. We proceed to the results section. We can see both negative control and Gutaflow Bioseal showed less than 20% mortality rate. 100% mortality rate was recorded for positive control MTA filler packs, Sarase Bioceramic root canal sealer, and IRSP root canal sealer. Moreover, zebrafish embryo survival rates for 96 hours post-fertilization in Gutaflow Bioseal was more than 80%, almost similar to the negative control group. In contrast, MTA filler packs, Sarase Bioceramic root canal sealer, IRSP root canal sealer showed 0% zebrafish survival rates for 96 hours post-fertilization. Furthermore, is the results for the hatching rate of zebrafish embryo. We can see in the Gutaflow Bioseal group, the hatching rate of zebrafish embryo increased at 48 hours of post-fertilization and at 96 hours of post-fertilization. More than 80% hatching rate was observed. Hatching rates takes place between 48 and 72 hours of post-fertilization indicate effective development of the embryo into larvae. Here are the general pictures for the morphology of zebrafish embryo after being exposed to bioceramic root canal sealers. We can see Gataflow Bioseal showed similar morphology as negative control group. Meanwhile, MTA Filopax, Serasi Bioceramic root canal sealer show coagulation of embryo as early as 24 hours post-fertilization. We move to discussion section. Higher mortality rates were observed in MTA Filopax, Serasi Bioceramic root canal sealer and IRSP root canal sealer compared to Gataflow Bioseal could be due to the different compositions of the extract materials. Moreover, differences in pH values between Gataflow Bioseal with pH 8, MTA Filopax with pH 10, Serasi Bioceramic root canal sealer with pH 13, IRSP root canal sealer with pH 13 could also explain the differences in mortality rates observed. Higher survival rates were observed in Gataflow Bioseal may be due to the differences in the uptake of different material constituents into the embryo and good inclusions of the appearance exposed material through the surface of the Korean zebrafish embryo. The hatching rates observed in Gataflow Bioseal at 48 hours post-fertilization was in line with the normal zebrafish model hatching rates reported in previous studies. Failure to hatch observed in MTA Filopax, Serasi Bioceramic root canal sealer and IRSP root canal sealer could be due to the failure of the chorion to rupture due to the developmental defects and morphological defects in the zebrafish embryo. Within the limitations of the present study, the conclusions that could be suggested is Gataflow Bioseal display low cytotoxicity compared to MTA Filopax, Serasi Bioceramic root canal sealer and IRSP root canal sealer. Therefore, clinicians should select Bioceramic root canal sealer with low cytotoxics during the root canal treatment procedure. Here are the references for the presentation today. That's all from me. Thank you.